Welcome to Math Olympiad. As I told you, let's start the IOQM paper, previous year paper. Okay. So this is part one. I will make it in few parts because it will take a long time if I put all the questions in one video. Okay. So Indian IOQM stands for Indian Olympiad Qualifier in Mathematics. Okay. This happens in stages for qualification of Indian Olympiad. Okay. This is the first level is IOQM. Okay, after that, some more levels are there. When I solve those problems, we'll go and understand those. So this paper will have 30 questions, all are multiple choice questions. Okay, 3 hours of time. Then question 1 to 8, that is 8 questions. First 8 questions carry 2 marks. Next 9 to 21 carry 3 marks, and 22 to 30 carry 5 marks each. Okay, so the level of complexity will increase as you go each section. Okay, so in this video we will cover the 1 to 8 questions, 1 to 8. Okay, let's start. Yeah, the first question is ABCD is a trapezium in which uh, AB and CD, AB is parallel to CD, and this is not case, this is parallel. AB is parallel to CD, and AB equal to 3 times CD. Okay, AB is 3 times CD. Let E be the midpoint of the diagonal BD. E is the midpoint of the diagonal BD. If area of ABCD equal to n times that of CDE, okay, what is the value of n? Okay, here this bracket denotes area, okay, of the geometrical figure. Okay, so this looks easier problem. Once you know what is the formula for area of trapezium as well as triangle, this is very easy. Okay, let's draw a altitude from AB to CD passing through E. Okay, uh, so the height is h. So we know that E is the midpoint of BD. So E will also be midpoint of this altitude because AB and CD are parallel lines. Okay, so any transverse will have same pass through the same midpoint, right? So the triangle height will be h by 2, whereas the trapezium height is h. So this will solve our problem easily. Okay, given that AB equal to 3 CD, since AB is parallel to CD, is the midpoint of transverse BD. E is also midpoint of altitude ABCD. Okay, E bisects the height h into h by 2, basically, correct? Yes. Now, area of trapezium is h by 2 into AB plus CD, whereas area of triangle CDE is half into h by 2 into CD. Okay, now you just replace AB equal to 3 CD we have, right? So everything will go into the same value under one variable. So area of ABCD is h by 2 into 4 CD, that is 2h CD, okay, or 8 by times h by 4 CD. H by 4 CD is nothing but area of CDE, correct? So it is 8 times CDE. So from here we can clearly see n is 8, right? So this is the easier problem. Next. A number n in base 10 is 503. Okay, in 10 base 10 it is 503. So, and in base B it is 305. Oh, sorry. A number n in base 10. Okay, n is base 10. We don't know what is the number. Okay, and it is 503 in base B. Okay, 503 in base B. It is 305 in base B plus 2. What is the product of the digits of n? So first you find out n, then you get the product of digits. Okay. So given that 503b base b equal to 305b plus 2, which is equal to n, correct? So you expand the form into the decimal. So it will become 5b square plus 3 because second 10 term is second this one value is 0, and here it is 305. So 3b plus 2 whole square plus 5, which is 3b square plus 12b plus 12 plus 5. You basically simplify it, you get this quadratic equation. correct? So if you factorize it, you will get b minus 7 into 2b plus 2. b minus 7 into 2b plus 2. So b will be either 7 or minus 1. It minus 1 cannot be the base, right? Base cannot be negative value. So b equal to 7. So base is 7. Now you got the n. So you take n equal to 307. This is sorry base 7. Okay. So which is 5 7 square plus 3, which is 248. Okay. So the number in 10 base is 248. Now what is the product of these digits? It's very easy. 64. This is also easy. Once you know how to expand convert from base B to 10 base, it's easy, right? So you should know always converting into 10 base. This is the way. Okay. So next, next one is if sigma k equal to 1 to n, 2k plus 1 divided by k square plus k whole square equal to 0.9999, then determine the value of n. Okay. This looks a serious problem. So first thing is best way is to simplify this expression given here, and then it is easy to find the answer. Okay. So I take 2k plus 1 divided by k square plus k whole square. K square plus k, I can write it as k into k plus 1. So I'm dividing this as 1 by k into k plus 1 into 2k plus 1, I wrote it as k plus k plus 1. Okay, because denominator and numerator will have same terms, even though it is multiplication in the denominator and addition in the numerator. Okay, so that is equal to 1. This one I wrote it as k plus 1 minus k. Okay, so again in terms of denominator terms. Okay, into this I split it into k by k into k plus 1 plus k plus 1 by k into k plus 1. Okay, now you will understand why this is, because you will get into a addition of terms which will be easy to solve the problems. So the first one will become k plus 1 divided by k into k plus 1. So it will become 1 by k minus k divided by uh, k into k plus 1 will become 1 by k plus 1. Okay, and here it will become 1 by k plus 1 plus 1 by k. So this is a plus b into a minus b format, right? So 1 by k square minus 1 by k plus 1 whole square, right? So we can leave it at this point because this looks easy if you put it in the series. Now sigma of k equal to 1 to n, 2k plus 1 divided by k square plus k whole square. You can write it as sigma of k equal to 1 to n, 1 by k square minus 1 by k plus 1 whole square. Okay, that is nothing but if k equal to 1, 1 minus 1 by 2 square, k equal to 2 plus 1 by 2 square minus 1 by 3 square, plus like that it will go on until n. N is 1 by n square minus 1 by n plus 1 whole square. If you clearly see, you can cancel the terms except this 1 and minus 1 by 1 n plus 1 whole square. Rest all the terms get cancelled, right? So this is nothing but 1 minus 1 by n plus 1 whole square, which is equal to 0.9999, right? So if I take 0.99 to the other side and 1 by n plus 1 to the RHS, then it will become 0.0001 equal to 1 by n plus 1 whole square. That is 1 by 100 square equal to 1 by n plus 1 whole square. From this, it's very clear n plus 1 equal to 100 and n equal to 99. Right? Just little moderate. It's not hard. You should not get confused to simplify the first the expression. Then it's easy. Okay? It's a moderate one. Next. If ABCD is a rectangle in which AB plus BC plus CD equal to 20 and AE equal to 9, where E is the midpoint of the side BC, find the area of rectangle. So first draw the diagram. ABCD is a rectangle, E is a midpoint on BC and AE is given as 9 and AB plus BC plus CD is 20. Okay, let's take AB plus BC plus CD equal to 20, AB equal to CD, right? Opposite sides. So 2AB plus BC equal to 20. And BC I can write it as 2BE because E is midpoint of BC. Okay. So BE equal to 10 minus AB. Okay. Let's just for simplification, let AB equal to X, then BE equal to 10 minus X. Okay. Now, rectangle AB is right angle triangle. Okay. So AE square equal to Pythagoras theorem I am applying. AE square equal to AB square plus BE square. Okay. So 81 equal to A is 9, right? Given 81 equal to x square plus x square minus 20x plus 100. That is 10 minus x whole square. So which means I will get a value of 2x square minus 20x plus 19 equal to 0. This is my equation 1. I'm not trying to find x here because I can see the area is this expression. Okay. Area of ABCD equal to AB into BC. AB is nothing but x. BC is twice the BE, that is 20 minus 2x. So area is nothing but 20x minus 2x square. Correct? So from this equation 1, I can see that if I take 2x square minus 20x to the RHS side, it will become 20x minus 2x square. From equation 1, this is the one. This is the area of ABCD. Right? So area of rectangle is 19 units. This is easy, right? Next, the number of integer solutions to uh, modulo x minus 20 2020, which is less than or equal to 5. Okay. So this is very easy. You just need to find a range. If I remove the absolute value of this one, okay, then it will become range of minus 5, absolute x minus 2020, okay, is less than 5. Minus between the range minus 5 to plus 5. Right? If I remove the absolute value here. Now I will add 2020 to all sides. Then it will become 2015 less than absolute x less than 2025. Okay. Now if I remove absolute x here, okay, I will get two ranges. Either it is from minus 2025 to minus 2015 and 2015 to 2025 on the positive side. Negative side, this is the range. Positive side, this is the range. Look at the bracket here. So minus, these limits are excluded, not including. Okay. So limits are excluded. If I count, I have a range of 9 in each of them. 9 here, 9 here. So the solution set consists of total of 18. 9 plus 9. So number of integer solutions is 18. This is easy, right? Next. Okay, what is the least positive integer by which 2 to the power of 5, 3 to the power of 6 into 4 cube into 5 cube into 6 to the power of 7 should be multiplied? What is the least number you should multiply so that the product is a perfect square? Okay. So this is very easy. Already he gave in a prime factorization. So only few terms are not in the prime. So just factorize it to uh, prime factor as 0, basically product of primes. So here 4 and 6 are not primes. So convert them basically. So it will become this, and finally you will get 2 to the power of 18, 3 to the power of 13 into 5 to the power of 3. Here we know 2 to the power of 18 square root you can get, correct? It's a perfect square, but 3 to the power of 13 is not a perfect square. 1 3 is missing, and 5 to the power of 5 cube also not a perfect square. 1 5 is missing. So minimum number I required is 3 into 5, correct? Then it will become a perfect square. So answer is 15. This is easy, right? Okay. Let ABC be a triangle with AB equal to AC. It's isosceles triangle, and D is a point on the segment BC such that BD equal to 48 1 by 20, 61 and DC equal to 61. Let E be a point on AD such that C is perpendicular to AD and DE, which is equal to AD, and DE equal to 11. Find AE. First, let's draw a diagram. AB, AC are equal. Okay, isosceles triangle. AD, D is any point on BC, is it? So BD is 48 1 by 61 and DC is 61. And a line is drawn onto from C to AD where it is 90 degrees. Okay. And we need to find out the value AE. Okay. DE is also given as 11. So we need to find this value. For that, I require one altitude. This is AF is altitude is at 90 degrees actually. Okay. Right. This is a 90 degrees. Okay. BD is I'll just for simplification first I want to give the values of XYZ to this one, and then in the end we will replace the values. Otherwise calculations will be little bit complex because we have a 48 1 by 16 value here. So BD equal to X, CD equal to Y, DE equal to Z. All three values are given. Okay. FC equal to X plus Y by 2. Okay. FC equal to X plus Y by 2 because F is a altitude 90 degrees here and F is the midpoint because it's isosceles triangle, right? Altitude will bisect the opposite side. Okay. So X plus Y by 2. Okay. FC or uh, BF. Both are same basically. Okay. DF equal to CD minus FC. DF equal to CD minus FC. CD is Y. So Y minus X plus Y by 2 which is equal to Y minus X by 2. Okay. Now next. Let's take triangle CED. CED. Okay, this is a right angle triangle at E. Okay, so CE equal to Y square CD square minus Z square square root. So square root of Y square minus Z square. Remember that. Draw AF perpendicular to BC. Okay, this is one. Okay. In AFT, this is a right angle triangle again. Correct? AF square plus DF square equal to AD square. Okay. So AF square, AD square equal to AF square plus DF. DF is nothing but y minus x whole square. Y minus x by 2 whole square. Okay. And in AFC, AFC, this is also right angle triangle. Okay. AC square equal to CF square plus AF square. So that is nothing but x plus y whole by 2 whole square plus AF square. So if you see these two equations here, only thing common is AF square. Correct? AF square, AF square. And AD you can write in terms of AE plus DE. DE you have value already, so only AE will be the variable. If you remove AF basically, correct? If you remove AF in these two equations, only variable is, and of course AC. AC is also you have to remove. Okay, let's see how to do. Okay, let's go to the another triangle CEA. CEA. This is also right angle triangle. So here AC square equal to CE square plus AE square. Okay. Now we got into replacing AC, right? AC square equal to y square minus z square plus AE square. Okay. AE square is a variable for which you need to know the value. And this AC square you can replace here. Okay. Then you will get only in terms of AE square and AF square. Now that AF square you replace here, then you get only in terms of AE square then. Correct? So this is what we should do next. Okay. So AD square equal to A square plus DF square. So AF square plus y minus x by 2 whole square. Okay. So y square minus z square plus AE square equal to AC square. AC square is nothing but x plus y by 2 whole square plus AF square. Okay. Which is equal to x plus y whole square by 2 plus AF square is nothing but AD square minus this one. Correct. So We are slowly replacing all the terms, and only now we are left with AE here on the left hand side, AD on the right hand side. Okay, so y square minus z square plus AE square equal to xy plus AE plus z whole square. Okay, why it is AE plus z? AD square is nothing but AE plus DE. DE is z. So AE plus z whole square, which is equal to xy plus AE square plus 2z AE plus z square. You simplify it, basically AE will be y square minus 2z square minus xy by 2z. You just substitute the values. You get the value AE as 25. Okay. Yeah, this is a bit hard actually, given the mm, class 10 knowledge basically. Okay, so now you guys can understand the level of IOQM, right? So this is in the easier section. Other questions are more tougher. So this is hard. So one question out of eight we found hard. Remaining are all mostly easy. Most of them are easy except one, I think, moderate. Okay. Next, there is a five-digit number in base 10, okay, and has digits k, k plus 1, k plus 2, 3k, k plus 3 in that order, same order from left to right. Okay, so these are the digits. Each digit can be, k cannot be 0, right? Because it's a five-digit number, k has to be 1 to 9. But these things, anything can be 0. But if k is not 0, none of these will be zeros, right? If this number is m square for some natural number m, find the sum of digits of m. Okay? So he's telling, if you put these digits as a number, then it is m squared in the form of m square. So you have to find out a number which satisfies these equations and in the form of m square. Okay. So first take easiest one, 3k. If you look at 3k, 3k is less than or equal to 9 because k cannot be 0, as I said. K is not 0. So 3k is less than or equal to 9. So what are the options it has? K can be either 1 or 2 or 3. Done. You just substitute and see all the digits. If k equal to 1, m square equal to 1, 2, 3, 3, 4. Okay, but 12,334 is not a perfect square. Okay, so this is not correct answer. K equal to 2, m square will become 23,465. This is also not a perfect square. So this is also not a solution. For k equal to 3, m square equal to 345.96. Okay, yeah, this is a perfect square. So m equal to 186. So the answer is basically you need to find sum of digits of m, right? Don't forget, answer is not m. You need to find sum of digits of m, which is nothing but 1 plus 8, 9, 9 plus 6, 15. This is the answer. I think this is easy, right? Easy. So that's all these first eight questions. I think one question is hard, but definitely these IOQM questions are much tougher than the SY5MO which I solved before, right? So this is the real IMO. So you understand the entry level first section questions, how they will be. In entry level itself, you have one of the questions which is hard. Okay, so this is the level. But with practice, you can always solve them easily. And whether a paper is tough or easy, it is for everybody, not for you. Okay, remember that. Thank you.